Welcome friends to my channel nirajkapase. So today we are going to see ESP8266 Node MCU. So this is a microcontroller chip with the Wi-Fi enabled. So this is specifically used as a node in a IoT. So this is having very good advantages and very superb functionality. It is having ADC on it, then GPIO is available on this as well, and it is Arduino compatible board. So you can use Arduino Ide for programming about this particular board. So we'll see first what are the features, how the board looks like, and then we'll see different programming interface of this as well. Okay, so here introduction to the ESP8266. So ESP8266 is a low cost Wi-Fi microchip with full TCP/IP stack and a microcontroller capability produced by the manufacturer ES Praise if systems, that is Shanghai from China. So they manufacture this particular device. So ES Praise if systems in Shanghai. Okay, so this chip came first into the market in August 2014 as named as ESP01 module. So earlier the name of this particular module is ESP01, made by the third-party manufacturer known as an AI Thinker. So AI Thinker is the company. They manufacture this particular board named as ESP01. This is a small module, allows the microcontroller to connect Wi-Fi network. So it's a very small module, and this allows microcontroller to connect to the Wi-Fi network. It is having TCP/IP stack connections using Hey style commands. So it uses Hey style commands for connecting with TCP/IP. However, there was almost no English language documentation on chip, and the command it's accepted. So it's all the commands are in Chinese, and that's why the popularity of that particular ESP01 is less. So after that, the very low priced, and the fact is very few external components and the modules required. That's why it is a popular, but they need to translate that Chinese documentation in English so that it becomes worldwide popular. Okay, so if the documentation, once the documentation is available in English, that's why this is very popular in the other market. So we'll see ESP8266 or ESP8285 is an ESP8266 with 1 MB of built-in flash, allowing the single chip capabilities and connecting to the Wi-Fi. So the module looks like this. So this is the module of ESP8266. Here we have different pin configurations. So here it is a A0 pin. So this is an analog pin. So next is G pin, that is a ground. Okay, ground pin, VU, S1, S2, S3, SC, SO, SK, then 3.3 volt, reset, V, VIN. Then here on this side we have D0, D1, D2, D3, 3 volt, ground, D5, D6, D7, D8, TX, RX, and all. Okay, here these are the two reset. One is a reset pin and one is a flash pin. So we can flash this particular thing and we can reset it. So this actually this is module, and this module is designed and developed by AI Tinker, and this module is having the flash inside it. So it is having a TCP/IP firmware stack, so that it's going to connect with a Wi-Fi with a security as well. Okay, so this is about the ESP8266 chip, how it looks like. Next we'll see the specifications of ESP8266. So ESP8266 Node MCU specifications. So it is 3.3 volt. It works with 3.3 volt. It is having Wi-Fi direct with SWAT application and peripheral interface, that is SWAP AP. Okay, then the current consumption of this ESP8266 is 10 microampere to 170 milliampere. So it's very less. Current consumption is very less. Also, flash programmable attachable memory is 16 MB maximum, and in the normal case that is 512 KB. So internally it's having 512 KB of normal flash. Integrated TCP/IP protocol stack is available on this. Okay, and it uses the processor named as Tensilica L106, that is 32-bit processor. So this processor is Tensilica L106 32-bit processor. The processor speed is around 80 to 160 megahertz. Okay, the processor works with the speed of 80 to 160 megahertz. The RAM is 32 KB plus 80 KB flash. There are normal GPIOs are 17. So multiplex with other functions as well. So in all together 17 GPIOs are there, and those are multiplexed with other functions. A to D, that is analog to digital converter, there is a one input only. Just now we have seen here, this is A0 input, one input only, and it is having 1024 steps resolution. So it is a 10-bit ADC, that's why the resolution is 1024 steps. Then it is having plus 19.5 dBm output power with 802.11b standard. So again it is a IEEE standard it supports, and it supports IEEE 802.11b, G and N standard as well. So maximum concurrent connections it supports till 5. So we can attach 5 different Wi-Fi. If you create a hotspot with this particular device, so maximum we can connect 5 different devices with this as well. Okay, so these are some specifications of NodeMCU, how the NodeMCU is to be. Then if you look at the pin description, so in detail pin description is available here on this particular page. Okay, so let's just this. Okay, yeah, here it is a pin description. Here it's having a VIN input, that is 5 volt, ground pin is there, then reset is there, enable pin is there, then 3.3 volt pin is there, then again ground is there, SCK, SCLK, that is again MISO, CS, MOSI. So these are the SPI pins. So this supports SPI, that is HSPI and SPI. Okay, then GPIO pins are there, GPIO 9, GPIO 10. These two pins are reserved. RSV stands for reserved, so these two pins are reserved. Then there is a one ADC only, ADC 0, so that is A0. Okay, so you can observe that these color pins are reserved pins, these are the ADC pins, these are the system pins, it is enable and reset. Okay, then next we have a key pins. So key pins are here, flash, user. So these are the key pins. So we have GPIO 16, this is a multifunction. So the D0 pin can be worked as GPIO 16, can be worked as user, can be worked as a VEC pin. Also GPIO 5, D1, GPIO 4, GPIO 0, GPIO 2. So GPIO 0 is again a flash pin and GPIO 2 is a TXD1. So it's having two transmitter and receivers. So you can use it as a TXD and RXD as well. So 3.3 is a power input. Okay, and the ground pin is there. Then we have GPIO 14, GPIO 12, GPIO 13. Again the RXD, TXD2, RXD0, TXD0. So again multiplexed. So here it is I2C bus. Okay. So this is I2C. Again, it is a multifunction named as SPI as well. So you can use it. This means it is D8 to D5, D5 to D8. This can be used as a multifunction SPI as well. Then the ground pin is there, and then the 3.3 volt pin is there. Okay, so these are the pins definitions of NodeMCU. Okay. Then how you can program this particular thing. So it works with there are two IDEs available, and you can run this particular board by using this IDEs. You can program for the programming. You can use two different IDEs. One IDE is Arduino IDE and second is ESP8266 IDE. So programmable software, the most basic way to program this particular module via the serial commands. So the chip is basically a Wi-Fi serial transceiver module. Then you can use Arduino ESP8266 project for programming this thing, and you can use a well-known Arduino IDE for this. And there are the steps for installing the Arduino IDE. First we need to install the Arduino IDE, that is requirement is 1.6.4 and greater. So you can download this Arduino IDE from arduino.cc or a greater version. Okay, so if you are using a lower version, that is 1.6.2, this will not support. That's why we need to install the higher version than 1.6.4. Then install the ESP8266 board package. So how you have to install the board package? For that, click on preferences. I will show you how we can do that. So I have already installed the Arduino IDE. So I will open the Arduino IDE and show you. So here it is, Arduino IDE. So I just double click on that. It just opens. Okay, till that time I will explain you this. So click on a file and then go to preferences. So once you click on a file, go to preferences. Here it is a preferences. Then from that preferences, we need to do use the following link on the additional board manager URL. So this is a link, and this link will support JSON link. So this supports the package of ESP8266. So you have to use this particular link. Okay. So this link is from arduino.esp8266.com/table/package underscore ESP8266com underscore index.json. So I have already taken that thing. So my version is 1.8.12. I will go to file and then preferences. So you can observe that. So I have pasted that particular link under the additional board manager. All right. So you have to paste this, and after that, what the thing is, after pasting here, so I have pasted it. Use the board manager to install the ESP8266 package. Click on the tools, then boards, then board manager, and access this panel. Okay. So how to access this? Again, go to tools, board manager, then under a board manager. So you have scroll down there. So install this package. So there is option available here. Go to tools. Then there is a boards. So you have to go to board manager. So you can search it here. So here there is a search option available. So it will download automatically the newest files. So you have to search here ESP8266. Okay. So it is mentioned that thing. So you have to type ESP8266. I'll select the ESP8266 by community and then install button. Then automatically the installed library will be getting installed. So ESP8266, if you type that ESP8266, I have already installed it. So like this you will get. So I have installed it, so I can update it now. So the updated version is available. That is, I have installed 2.6.3, but the current version is updated version is available there. So I can install this as well. Okay. So this supports many of the boards, like it supports generic ESP8266 module, generic ESP8285 module, then ESP pin, Adafruit feeder board, Huzaha board, then Invent one, and then Zyna box or Espresso board. Then we have Phonix 1.0, Phonix 2.0, NodeMCU 0.9, NodeMCU 1.0, that is ESP12E module. So currently I am holding ESP12E module. Then Olimex mod module, SparkFun ESP8266 thing module. Okay, so many boards are there. Then Lolin boards are there, VMOS boards are there, VMOS D1, then VMOS R1, ESP Pino and all. So these boards are there. So I will show you, I have few of the boards with me. So I have VMOS, I have Adafruit feeder, Huzaha, then NodeMCU 1.0, NodeMCU 0.9, then I have another board known as where is Lolin I have. So I will show you those particular boards in the next upcoming lecture sessions and the video sessions. Okay, so like this we need to select, and then here install button is there, so we need to install it. Once you install, you will get here ESP8266 community and then the remove button. So just now we got. Then go to support. So set up ESP8266. Go to restart the Arduino Ide. Click on the tools, boards, drop down, and NodeMCU ESP12 module. Either if you are using 0.9 module, then select this 0.9 module. If you are using NodeMCU 1.0 module, then select 1.0 module and all. Okay, so here it is a selection. So we have to go to this ESP module and then select this 0.9 module or 1.0 module. So select the frequency is 80 megahertz. So here there are few commands. What are the things we need to do? I'm going to tell you. The thing is, go to tools, then go to this. So I am using 1.0 module, so that's why I have selected this 1.0. I have installed many of the boards, so you can look at this. So I have this Huzaha as well. So 1.0 module I have selected. Then bulletin LED is 2. Speed you can keep it is 115200. CPU speed is 80 megahertz, so don't change it. Then flash memory is a 4 MB, don't change it again. Debug port is disabled, so if you enable the debug port, then everything will be displayed on the serial monitor. So you have to disable that. Debug level is none, so you can debug your coding level, that is SSL, or we can have HTTP client and all. So whether it's connected or not connected, what are the errors, what is the connection issue with the Wi-Fi and all. So those things we can debug. So all the events will be triggered on the serial port. So you can read those particular events and read those particular triggers. Then we have LWIP variant is that is V2, that is low memory variant. So you can use different variants as well, like lower memory, higher bandwidth, lower memory, no features and all. So by default selection is low memory. So V tables you need to use as a flash because we are flashing this particular thing. Exceptions as a latency. Then erase flash on sketch. So this program is known as a sketch. That's why we have to erase the erase this particular thing with a sketch. SSL, that is secure layer support, is same ciphering. So ciphering is most compatible use. Get the board info. So once you click on get board info, you will get information about the board. So once the board is connected, you will get all the information like board serial number and everything. Right now I have not connected this particular board, that's why it's not showing this thing. But once it is connected, I will get all the info. So programmer is AVR MK2 and bootloader, keep it as it is. Okay. So once I connect this particular board, so what will happen? So I will connect this board to the USB. So I have this board with me. So I'm going to connect with a micro USB cable here. So micro USB cable is there. So I have connected this micro USB cable and connect another port towards this side. Okay, once I connect, so it requires drivers again. So from where you need to take the drivers, I will tell you. So once I connect, it uploads the board package. Here the COM3 is getting updated. If I click on a board info, so you'll get the information of the board. So upload the any sketch to obtain it. So once I upload the sketch, it will give a serial number, it will give VID, PID. So why for this it is required? If you are like programming for any of the product, and if you want to do that product is to be secured one and your program is to be secured one, then you can put the serial number in the program, so that that program is valid for only that particular IC or that particular board. So if you are not doing that, then anyone can just read the hex file and then they can upload it in another drive and your program will be stolen. So that's why it is better you can copy the serial number and then you can use that particular serial number for security. Okay. So okay, that's it about this. So these are the settings. Then we have done with the settings. So this I have explained already, baud rate and all. Okay, and then another thing is go to device manager and install this USB serial CS240 library. So you have to download this USB serial 240 library so that once you download that thing, you will get serial COM port. So the COM port is assigned here. So COM is available, that is COM 11. Okay, so COM 13 is there. So I've selected that COM 13. Then I will show you how you can program this particular thing. So first program is LED blink program. So I will go and open the example. So I will go here, open example of ESP8266. Here it is ESP8266. I will go and open the blink example. So here it is, a blink example is available. So I would open this blink example. So what this will do, this will turn on the bulletin LED on and off for each and every 1 second off and 2 second on. Okay, so this I need to program it. So I will go to tools again, select this COM port, this COM3 is selected, and just hit the upload button here. So this is a compile button, verify button. So if I click on a verify, so it just go on verifying all the things. So here I have enabled the debugger like verbose. So that is known as in verbose. So I have enabled the verbose, that's why it shows all the commands and listing here. So on this side it is displayed, so which are the things it's doing right now. So using the board and all, so these things will be displayed here, detecting the library to be used and all. Okay, how the hex file is created, which are the different support packages it's going to use, and how it's going to create all the things. So this IDE is written in the Python. Okay, again Python is very popular language for the IoT. Okay, we'll wait till it's going to complete. So this just I have pressed the compile button, so it's just going to compile it. Okay, so I will till that time I will explain the code. So here the void setup and void loop, there are two functions. So under a void setup, we need to do setup things like pin functionality setup and all. So here LED bulletin is the pin, on board LED is available. So that LED is output device. So that's why we have made that as an output. So initialization has been done here, pin mode, LED bulletin, comma output. So this is LED has been output. Then void loop, it's another main, just like a void main. So void loop digital write is again a function. So digital write LED bulletin, again the same LED bulletin we are using, and low. So this makes that LED off. Okay, then sorry, here it is active low, that's why this makes the LED on. Okay, and digital light LED bulletin is high, so this makes LED is off. Okay, when we send high, the LED is off. When we send low, the LED is on because it is active low. Okay, so right now it's compiled, so you'll get the information here. The sketches that's been compiled, so maximum memory space it's used is 24%. Then 26804 bytes, that is 32 dynamic memory percent dynamic memory is used. Maximum is 81920 bytes. Okay, then global variable used is 26804 bytes, that is 32% of a dynamic memory, leaving 51116 bytes for the local variables, and maximum is up to 81920. Okay, so this has been explained here when you compile it. Now I can program it. So for programming, here it is upload button, just hit the upload button. Again it's going to compile the things again, and then it's create a bin file. That bin file is been uploaded inside this particular board. Okay, so once it's been done, so you'll get done symbol here. Okay, so right now it's uploading. You can observe that LED is blinking here. So percentage is 8% is uploaded now. So here it is uploading symbol, and 8% has been uploaded. So you can observe that. So right now it's 16%, 25%, 33%, 41%, 50, 56, 71, 81, 91 and 100. So once it's been done, it will reset the pin automatically and done uploaded. So you can observe that the LED is blinking. So this LED is onboard LED, so named as LED bulletin. So this LED is blinking. Okay. All right. So this is the thing how you can blink the LED. Okay, so so this is about how you can use ESP8266. All right, so for today we'll stop here. Okay, and again, those who are not subscribed my channel yet, please press subscribe button and also press notification bell icon for next upcoming updates. Thank you for listening. Thank you.